All right, so this is how you basically finish the problem. We want to find the tension or compression in member AC, in member AB, and in member BC. So there's three members here. We need to find if they're either in tension and compression, and how much tension or compression. So the very first thing to do is we need to find our angles. We need to find what this angle is and what this angle is. So to do that, if you were to bring this down and kind of create a right triangle, just focusing on member AB and from A to B, you'd have this triangle right here. You'd have from here to here. The base of that is 29. We know that's a right angle. And we're trying to find, let's call it theta right there. And then all the way up, the distance is 10. So this is where you do, because, if you write down SOHCAHTOA, because you have 10, which is the opposite, and 29, which is the adjacent, we're going to end up using tangent. So to write the trig ratio, it's tangent of theta is equal to 10 over 29. But then you need to solve for the angle. So to solve for the angle, you need to use inverse trig of 10 over 29. Again, anytime you're doing trig on your calculator, you need to make sure your calculator is in degrees, which mine is. If it's not, you need to make sure it's in degrees before you do this. And then to do the inverse trig, you hit second tangent, and then the ratio is 10 over 29. And it's 19 degrees. So the angle here is 19 degrees. So we know that this angle is 19 degrees. Okay. Likewise, if we just look at this triangle on this side, it would look like this. So from C to B is 16 feet, so that's 16 feet. From C up to B is still 10 feet, makes a right triangle. And now we're looking for this angle. And again, it's still the same trig function because 10 is the opposite, 16 is the adjacent. So you're still going to use tangent, but it's going to look like this. Theta is equal to the tangent inverse. You always have to use the inverse anytime you're trying to find an angle of 10 over 16. So again, it's second tangent of 10 over 16 this time. And you get 32 degrees. So now I know that this is 32 degrees, this is 19 degrees. So now if we just look at, we focus in on pin A. If we focus in on pin A, we have member AB and we have AC. So let's kind of focus in on that. And we would have AB going in that direction. If here's A, that's pin A. And then at pin A, we found AX to be 0, right? So there's really no force happening in that direction. But we did find AY to be 604.4. So there's 604. Oops, sorry. Let me bring it down. There's 604.4 in the Y direction. That's the reaction force in the Y direction at pin A. In AB, you could draw the component forces of AB. So AB really consists of ABX and ABY because it's happening at a diagonal. And we know that that's 19 degrees. We just found that. So the very first thing to do now is we basically need to set up equations for AB in the x direction and AB in the y direction. So to do that, we just use a simple trig equation. So if we're going to focus on ABX and use the hypotenuse, that would be cosine because we're using the adjacent in the hypotenuse. So ABX is equal to the cosine of 19 degrees. Let me just actually. The cosine of 19 degrees is equal to ABX. I was going to skip a step. Divided by AB. So it's basically the cosine is equal to the adjacent over the hypotenuse. And now if we were to solve for ABX, you'd multiply by AB. So essentially AB times cosine 19 is equal to ABX. And then likewise, we could do that same type of math to solve for ABY. But this time, if you cover up ABX, ABY is the opposite, and we're still going to use the hypotenuse. So if the opposite in hypotenuse is sine. So it's going to be the same exact equation, except instead of cosine, it's sine. And that's going to be for ABY. So now we have our two equations for ABX and ABY. And now what we're going to do is we're going to sum the forces in the y direction. The sum of the forces in the y direction have to equal 0. Okay, so the forces we have in the y direction are ABY and the 604. Those are the only forces in the y direction at pin A. And again, we have member AC, but AC is a force completely in the x direction. There's no y component to it. So the forces in the y direction are just the positive 604 and the ABY. But again, what we did in class is we know that ABY is equal to AB times sine 19. So we could replace ABY with AB times sine 19. And that has to equal 0. So now to do this, to solve this, you subtract 604.4, and I'll kind of do this up here. So it would be AB times sine 19 is equal to negative 604.4, and then you divide by sine 19. So AB is equal to negative 1,856.45. And because it's negative, it's in compression. So what we did is we looked at just the component forces of AB. AB has a component force in the x direction and the y direction. And then we wrote two equations. Here are the two equations. And these equations are going to be the same basically every single time, except, instead of cosine 19, you replace it with whatever angle you get. So your question is going to look different. It's obviously not going to be 19. It's going to be something different, but ABX is still equal to AB times the cosine of whatever angle you get. ABY, likewise, is equal to AB times the sine of whatever angle you get. And then you sum the forces in the y direction. So now if we sum the forces in the x direction, those also have to equal 0. So the forces we have in the x direction, again, at pin A in the x direction, we found AX to equal 0. So AX has a reaction force at the pin of 0, so we don't really need to include that. AY is a y direction, so we don't need to include that. All right, sorry, I was getting a phone call. All right, so now we're going to sum the forces in the x direction. So the forces in the x direction are AC, that's an x component force, ABX, and I believe that's it. The only two forces in the x direction are AC and ABX. So we don't know what AC is, so it's going to be AC plus ABX. But again, we could replace ABX with AB times cosine 19. So those are my two forces in the x direction, AC and ABX. But again, ABX is the same thing as AB times cosine 19. Now the next thing we could do is we already know what AB is. So AB, this is a force. We know what that is. It's that right there. So we could replace that AC plus a negative 1,856.45 times the cosine of 19 is equal to 0. This is just going to equal a number. So when we do that, you get AC minus 17,000, what is it, 1,755. Man, I can't speak right now. 1,755 0.31 is equal to 0. Then you add that over. So AC is going to end up being positive 1,755.31. So because it's positive, it's in tension. So what we did so far is we solved for AB and AC. We solved for two of the three members. We found AB to be in compression and AC to be in tension. So now all we have to do is solve for the last member, member BC or CB, however you want to denote it. So now we basically have to do the same thing, but look at C. Okay, so if we draw that same kind of triangle, but now we're looking at C, this is member BC. AC is coming in from this direction. CY was 1,095.6, right? That was from the very beginning, CY. AC, we just found it to be in tension, so it's going in the positive X direction towards C. And then BC has component forces, BCX and BCY. And they're the same exact equations we found over here. You could basically replace this. BCX is equal to BC times cosine, and this time we're not going to use 19, we're going to use the 32. So times the cosine of 32, and then BCY is equal to BC times the sine of 32, because we know that angle is 32, the different angle than we got over here. So you really just need one other formula to solve for BC, and that would be summing the forces in the y direction. So the forces we have in the y direction are the reaction force at the roller C in the y direction and BCY. So we have a positive 1095.6, and then we have plus, we're going to put BCY, but BCY is equal to BC times sine 30, because BCY is in the y direction. So BC times sine 32 is equal to 0. Solving this for BC, you would subtract, so basically BC is equal to negative 1095.6. You'd subtract that and divide by sine 32. So BC is equal to a negative 2,067.48. Okay, so to sum it up, I'll put my answers at the top. We have AB is negative 1856.45 in compression because it's negative. Then we found AC to be in tension because it's positive. And then the last one we found was BC, or you could say CB, same thing, is equal to negative 2,067.48. Because it's negative, it's in compression. And now we solved the truss. So basically, we know every single member, if they're in tension or compression, how much tension or compression, and we solve for the reaction forces at the pin and roller.